Hello there. In this video we're going to take a bit of a deep dive into how to change the behavior of specific DockShell functionality. And in this scenario we had a recent inquiry from a customer who wanted to change the behavior of floating windows such that as the user navigated from one ribbon tab to the next, that the floating windows associated to the one ribbon tab that were open would close. And then when the user would navigate back to the to the ribbon tab where that floating window was hidden, they would show up again. So we'll show you how the default behavior behaves, and then we'll take you through how to make the code changes to implement that. So what we have here is we actually have the floating windows project, which is a simple LightSwitch application based on the Northwind data set, consisting of 6 screens, and those screens are situated in navigation groups as follows: a customers navigation group, employees, orders, and then administration. Under the covers, from a DockShell perspective, if we look at the actual DockShell model itself, we'll just expand that and take a look at that. And if you're not familiar with DockShell models and so forth, I highly recommend that you watch the introductory videos associated to that. As you can see here, we have a very similar setup as we were looking at earlier. So we have the customers, we have the employees, and the various screens that are associated to that, and we have the orders themselves. And so if I run this application, which I'll do right now, you can see when the application spins up, it actually has the 3 ribbon tabs: customers, employees, and orders. And that if I was to, for example, hit the search button, you can see that have the search button, the customer search window is actually coming up as a floating window. And if I hit the customers window, it comes up as a document window. So the behavior that our particular customer was interested in is to basically, as we move between tabs, you notice that the document window disappears, but the floating window remains. And what they were looking for was to basically have this window disappear so that it does not show up when you navigate between the various views. So the idea would be that if I had employees open, for example, I would be able to navigate back and forth, and I wouldn't have the search window still for the customers on the employees tab. So it's a behavior that they were looking to introduce specifically for their particular application. So let's take a look at how you would do that in DockShell. So the first thing that we need to do is kind of locate where a starting point, if you will, for the change. And what we do know is that we are dealing with a telerec provider, and in the telerec provider, we have, in our situation, we have a set of ribbon tabs that are associated to one or more, to a ribbon view. And what we want to do is we want to anytime there's a change at a ribbon tab level, we want to check to see if there are any open floating windows associated to that particular ribbon tab, and to make them invisible and then allow the user to navigate to another tab. And if there were hidden windows, floating windows within that other ribbon tab, to show those, so back and forth, so to speak. So we know for a fact that the place that we want to sort of start is this DockShell ribbon view control view model. And this is the view model that's associated to the ribbon view itself. And so if we simply scroll down, we will see this selection change. So this event is fired when a rad ribbon view navigation is made by the user. So in other words, when the user selects a ribbon tab. And so what we're going to do is we're going to add a bit of code, and I'm going to pause the video and I'm going to come back and explain the changes that we've added. All right, welcome back. So you can see here that we've added a bit of logic to this particular view model. And in this first area that we want to point out, this first code change is associated to adding a particular DockShell framework runtime instance using the import statement from math. So essentially what this has done for us is that it has now allowed us to bring in the DockShell core service proxy, which is really, I guess, a back-end gateway to the DockShell framework, and allows you to interact with all of the instances that DockShell is creating as it's running. And so if you notice here, this import tag specifically tells MEF that when it's creating an instance of this particular backing view model for the rad ribbon view, to also go ahead and resolve this reference here for this DockShell core service proxy. You'll notice that we've added this call to this method, this new method called remove floating on selection change, and we're passing in the argument that's received on selection change. So the argument that we receive actually has the items, added items, in other words, the tab that we're moving from and the tab that we're moving to, so added and removed. So if we take a look down here at the actual method that we've added, the first thing that we're doing is we're ensuring that this core service proxy is not null, in other words, available. And then we're grabbing a reference to this DockShell core navigation service. The core navigation service provides us with some insight into those ribbon tabs, and the actual instances themselves is what we're interested in looking at. And so the first thing that we do is we cast off from the removed items as an DockShell navigation control. So this is basically coming in as a rad ribbon tab, but because we know that DockShell has actually constructed this based on your model, we're able to basically get the exiting navigation control as an DockShell navigation control. And we want to do that. And we want to be able to do that because specifically as we leverage the navigation service and we look at the instances associated to all navigation containers, in other words, all ribbon tabs in this scenario, we're looking to see that we can get a reference to the specific navigation container based on the navigation control that's the user's moving to and from. So in this case here, we're looking to locate the exiting navigation controls navigation container, and once we have that, we can then get the content container control, which in this scenario is actually a rad docking control. Because in DockShell, within the model, you can actually share docking areas between ribbon tabs. We can't make any assumptions around a one-to-one relationship between any rad docking control. So this is why we go through this process of obtaining the rad docking control associated to a specific ribbon tab by looking at the navigations collection, navigation container collection. That's a mouthful, but at the end of the day, we end up with a rad docking control. And now we're looking at the pure rad telerec sort of logic here, where we're enumerating through the open panes associated to that docking area. And specifically what we're looking for here is any pane, rad pane that is currently floating. And if it's floating, what we're going to do is we're going to simply create this very simple instance of this hide view action view model. It's a very simple view model that we added, and I'll just take a look at that right now. You can see here there's not much to this particular class other than there is a simple enumerated list, which has a public attribute associated to the view model of that type. And all we're doing is we're just basically setting that to be hide float and associating that to the tag itself. With that set, we can then hide the view. Now, you might be wondering why we're doing this. Well, in DockShell, if we don't do this, the core behavior, when a window is hidden, it'll automatically close that window. That's the sort of the default behavior. And where it does that is actually in the DockShell dock control view model. So this is the view model that's associated to each one of these docking controls. So let's take a look at that. And let's take a look specifically at where that's happening and why that's happening. So if we scroll down here in this particular class, we're going to eventually find the rad docking close and preview close. So depending on the provider that you're using, the implementation of this will be different, and it's based on the events associated to that provider. So some providers actually do it from a much higher level than at a docking level. But in the Telerik scenario, it's actually done at the docking level, and so when a window is being hidden, it'll automatically call through this rad dock preview close. And what that does is it actually, in our default behavior in DockShell, it'll automatically call this underlying base method for this particular view model called content container view closing and pass in that view. And the net effect is it will actually close the window. But we don't want it to close. In fact, what we want it to do is simply hide the window and not close the window. So if we add a bit more logic, I'll pause the video and come right back. Welcome back. So you can see here what I've done is I've added this little bit of logic here, which essentially casts this specific view into a rad pane. And then what we're doing is we're looking for that tag that was set previously, or not set if it wasn't, it didn't run through that logic. And if it is set, it's looking to see, it's basically taking the tag and it's getting the instance of this view hide action view model. And if it does find that, it simply, and it is set to float, it simply returns. So it ignores this call, which would prevent the window from closing. So a very simple bit of logic to do that. And we're good to go on that class. So let's go back now to our ribbon view model and just kind of revisit exactly what we did. So we created this particular view model. We've associated it to the tag, and so that when the user closes this, or when we actually set this to true, it will cause this event to fire, which is a preview in the particular docking control instance that we associated to that ribbon tab. And instead of just letting it fall through and actually close the view, we're actually testing to see if that tag is set to that specific instance, and we're returning. So that basically gates off the ability for that view to close. Now that's if we're moving away from a particular ribbon tab, but what about when we're moving to ribbon tab? So in other words, let's say the user has hidden the window, has navigated from a tab where there was a floating window, and now we're coming back to that same tab where that window was hidden. We want to be able to restore that view. And so it's basically almost an identical loop, so you could probably refactor this and optimize this a little better than what we have here. But basically what we're doing is we're now looking at for the entering navigation control. So we're again searching the navigation services collection of navigation containers and looking specifically for the navigation control that we're moving into. Once again, we look at the content container associated to that navigation control and get the docking area associated to that. And then we build a list of any panes that are associated to that docking control that are currently hidden. And then we enumerate that list of panes, and we look specifically at each pane to see if there's a tag. And if there's a tag and it is set to this view model and it is set to this enumerated value of hide float, we remove the tag and we say is hidden is true. Okay, so that's the changes. Now let's take a look at how it works as far as in the code itself. And so what I'll do is just give this a quick build, make sure there's no errors on our provider. And there are no errors, which is good. All right. And now, because this is being demoed this way, we're going to basically re-reference the provider that we have right here. So I'm just going to remove this reference and re-add it. Here it is. There's different ways that you can do this. You can actually have the provider so that it builds and automatically puts the built instance of the provider directly in your project. Okay, so that's that done, and now we're going to do the same thing on the client generated. So in Visual Studio 2010, you have to do it both on the client and the client generated projects, those references, include those references. And to get to the client generated project, if you're on your floating window, in other words, the actual solution, your LightSwitch project solution, simply just toggle the hidden area here and you'll see the client generated project. we're going to do the same thing. We're just going to remove this and then re-add it the same way. I'll just pause the video and come right back. And I wanted to point something out. One of the techniques that we use to ensure that, when we have the provider project associated to our LightSwitch project, in order to make sure that this version, that when we compile it, actually shows up inside the LightSwitch project, what we like to do when we're developing is simply go into the properties of the project, and in the post-build event for the provider itself, we make sure that we're copying the actual assembly. In this case, we're looking for the debug version of the provider from its project bin folder, debug bin folder for the provider itself, and we just simply copy that into the LightSwitch. It's a very specific location. It's within the project's private extensions, a LightSwitch DockShell client reference, and that's where we stick the actual provider. So that's just a little bit of insight in how we do it. There's probably different ways that you can do it, but the idea being is that if I make a change here, I want to be able to debug my provider project simply by just doing a build, and that's actually what will happen. The other technique, obviously, is to ensure that when you're in debug, that when you're reference it as a project. So reference your provider here through a project reference to this particular project. After you've built everything, you can go back to just referencing as a direct assembly. So let's take a look now if we run this application and see what changes we've implemented. All right, so here's our LightSwitch application, and you can see no changes. So now if I open up the search customers window, what will happen is it'll open it up. Since we left it last as a floating window, it'll reopen it up in the same position as it did before. But now if I flip onto the tab, you notice that it disappears, right? And I flip back, it reappears. So that's nice, because now if I open up the search employees window, and what we'll do is we'll float this window as well. So we'll just pull this up and make it floating. Right? And if I go back to here, I should see now my search window, and my employee window reappears when I flip back here. And likewise, if I was to open up my search orders window and do the same thing. So we'll make it a floating window. And just pull that up. Do whatever we need to do there. There we go. All right. So now I think we've achieved the behavior that we were looking at. So as I navigate to the Employees tab and back and forth, you can see that we are achieving the exact desired behavior that we were looking for. So now I can open up my orders screen, which is actually going to be a docked document window, and I can search for specific items within this particular control. But as I go to this particular window here, you'll notice that everything goes away, and I'm actually looking at my searching window floating for my employees. So that's in fact the example that we wanted to sort of illustrate, and we've sort of now achieved the behavior that we were looking for our particular customer, and we've given you insight into the underlying controls associated to DockShell itself and services. So if we close this down and we look here, we can see we didn't really get into too much depth into this particular core proxy service, but just for example, what we'll do is just kind of take you through, and you can see here there's quite a bit of extensibility offered up within this particular service proxy, and it's essentially, as I say, this is what we use within the actual framework to control every area of DockShell. And so you have the ability to go in and modify this, get a reference to it. You can see you get properties, whether it's licensed or not. You can't change them, obviously, but at least you can see that they're there. It's kind of nice to see. It's real easy to get an instance of that using MEF. You just simply put the import tag in any view model or in any piece of code, whether it be inside your provider project or inside LightSwitch itself. We actually provide or give you an instance of this automatically out of the box when we build the provider model itself. So if you, for instance, go to, we'll just close these windows here, for example. And what we'll do is close this window. We're just going to take you real quick to the client project, and specifically the model itself. So the model that we were looking at earlier is this model, and when you save the project, it generates a T4 template, which then code generates out this backing logic, which is really just the model in partial class form. But one of the things that we do, and there's a pretty good video that sort of explains this, is we provide extensibility override capability on the startup of your model, your application. And so, for instance, you can override this initialization and do whatever you want. But part of what we also provide is we provide a public reference to the same DockShell service proxy. And we do that so that within your application, say within a screen or whatever, I can pick a particular screen, so I will do that. I'll pause the video and I'll show you. So I've just flipped over to the floating window, and I'll just close this now. Close that so it's clear. And so now what we're going to do is we're going to kind of look at adding some logic to this particular screen, and then using that same service proxy to do something different. Okay, so let's, for instance, say that we've added a command here, a new button. And if I was to just double-click that particular command, what we should be able to do is basically reference this directly, because this particular class is actually associated to the application instance, right? So all we have to do now is reference this directly within with whatever LightSwitch backing class that you want to make changes to. So essentially, you can get a hold of that same service proxy and do interact with the back end of DockShell just as easily as you do within the view model. The only difference here is that because you're on you're actually on a different thread, you do have to use the dispatch methods anytime you're interacting with back-end instances of objects within DockShell. And that's very typical of any LightSwitch sort of interaction that you have with any LightSwitch backing view models and so forth. And services and controls and controllers. You definitely need to use the dispatch method approach to be able to interact at the back end. All right, so hopefully that's given you sort of a clear understanding as to how things work in DockShell, and specifically around the actual changing behaviors for the floating windows. If you're interested and you have additional ideas that you want to implement within DockShell, we will have more documentation, as I mentioned, on the service proxy API, and in coming weeks and so forth. So please check the website and check our documentation for further updates. But as mentioned, there's pretty much a full extensibility once you understand how to access various instances within the framework itself. So thank you very much, and hope you have enjoyed this video. Cheers.